All right, guys, let us start with today's lesson. Okay, this is lesson number 3. This is lesson number 3 for your Form 4 chemistry. Okay, so now let's see what we need to know, what we will learn throughout today's lesson. Okay, so today we're gonna continue with explanation part of heating curve. So heating curve, we still left a little bit more to go. And then today we will start with cooling curve as well. And today we also do some subjective question. Today we will do some subjective question for the heating curve. So this is the purpose for today's lesson. Okay. All right. So let's take a quick 5 to 10 minutes to revise what we covered in the past lesson. So in the past lesson, we learned something about heating curve. Okay, so we learned about heating curve as well as cooling curve. All right. So heating curve and cooling curve, they are a graph. This graph is temperature versus time. So for the heating and cooling curve, okay, anyone can remember what is the shape of the graph? The shape of the graph is a staircase, isn't it? It is a staircase. Okay. So if the staircase is going up, so it's heating curve. If the staircase is coming down, then it is a cooling curve. That's it. How many staircase we can have? Maximum 2 staircases, maximum. Okay, so we can have 1 staircase or 2 staircases. Okay, so cannot be more than 2 lah. Okay, let's say this is 2 staircases. This is 1 staircase, for example. Yeah, and then this is cooling curve, 2 staircases, and this is 1 staircase. Yeah, so how to know how many staircase we have? Look at the horizontal line. Okay, so the horizontal line will tell us how many staircase you have. Like example, like this. I saw 2 horizontal lines. I know there are 2 staircases. Okay, so in the last lesson, we focused more on heating curve. We didn't started anything on cooling curve yet, which is what we will do today. Today we will do cooling curve. But before that, let's do some exercises on that. Okay, so heating curve, you must know heating curve is used to what? Used to do what? Heating curve can tell us the melting point as well as the cooling point. Yeah, so we can find the melting point and cooling point from our heating curve. Yeah, so remember when you have 2 staircases, the first staircase is melting. The second staircase is boiling. Yeah, so that's it. All right, because we know melting always come before boiling, isn't it? It always melt first, then only boil, isn't it? All right, so now, okay, what else we need to know? Okay, what else we need to know over here? Okay, so we also need to know something like this. Okay, uh for the experiment, how to carry out the experiment for heating curve. So when you want to carry out experiment for heating curve, we are doing indirect heating. So what is indirect heating? You go to use a water bath. It can be water bath, it can be oil bath, it can be sand bath. Yeah, so we go to heat the water or the oil or the sand in the first place. Then eventually, then only we use the hot water, the hot oil, or the hot sand to heat up the substance we wanted. So this is called indirect heating. So why we want indirect heating? Because indirect heating can ensure the heating is more uniform or more even. So we want the heating to be uniform. Uniform means what? Here, 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 and here. The heating is equal. Every part is being heated equally. You don't want this part being heated a bit more than this part. You don't want that. Yeah. So this is why we need to use the water bath to do the indirect heating. Okay. So remember, when should we change the water bath to become oil bath? Okay. Or sand bath? We change the water bath to oil bath or sand bath when you want to heat the substance to a temperature which is more than 100 degrees Celsius. When you heat the substance to more than 100 degrees Celsius, the water will boil. When water boil, they will become steam. They become gas. The gas will run away to surrounding, and sooner or later, the water become lesser and lesser. Then the water will dry. The water will dry up. You don't want that, lah. So make sure everyone know, when you should replace water bath to oil bath or sand bath. Okay. So, and then we must know how to sketch the heating curve. I told you, heating curve, when you have two horizontal lines, the first horizontal line is melting, second one is boiling. This is where melting started. This is where the melting ended. This is where the boiling started. This is where the boiling ended. And they always love to ask you the state. Okay. So I told you before, when you are on the slanted line like this, when you are on the slanted line, you only have one state. Like you are only solid, you're only liquid, or you're only gas. That's it. But when you are on the horizontal line always have two states. Why? Because horizontal line is where melting and boiling ongoing. When melting is ongoing, when melting is happening, so you will have solid and liquid together. When boiling is ongoing, you will have liquid and gas come together. So remember, when you are on the horizontal line, you will have two states. When you are on the slanted line means this, okay? You always have one state, okay? So that is everything that we covered. This is everything we learned in the past lesson. I hope you guys still remember this. Yeah, I really hope you all still remember this concept. Yeah, it's not very, very hard, okay? Heating curve, it's perfectly okay. Yeah, so now, okay, let me know in the chat box, how's everything? Are you okay with the revision? Do you still remember the heating curve concept that we learned last week? Let me know in the chat box. Are you okay with it? Okay, same thing, guys. If you are new student, this is your first lesson, most probably you will feel very blur for today, which is okay. Yeah. What you need to do is watch back the recording. What you need to do is that just watch back the recording for the previous lesson, which is your lesson number 1 and lesson number 2. Yeah. So it's completely normal that you feel blur because you come in, this is already lesson number 3. So if you don't understand, it's okay. So no worry, you will be able to catch up with us very, very soon. Okay. So now what we want to do today. Okay. So today, for the first probably 40 minutes to 50 minutes. Okay. Today, the plan is this. For the first probably about an hour. Okay. We will learn how to explain the process happening in the heating curve. We need to know how to explain. And after that, we will go to do some good quality question, structure question. Because for last lesson, for last week, we only do objective question. So objective question, worst case, you can tembak, isn't it? If I don't know how to do, I can try my luck, A, B, C, D. I can tembak. But for structured question, if you really don't know, you really cannot answer one. And you really cannot tembak one. You see? How are you going to tembak? If you really don't know how to answer the question, you cannot tembak anything one. Yeah? So that's why in this case, we really, really need to know how to explain, how to solve this question. So this whole process will take about an hour. Then another 30 to 40 minutes, I will touch a little bit on cooling curve. That's it. So that's the purpose. If you fully understand heating curve, if you guys fully understand what is heating curve all about, cooling curve is very, very, very easy for you. Okay? All right, so without further ado, let's start with the learning today. Okay, just now we only do revision. So now I want you to know how to explain. See, the things looks very long, right? Looks long and complicated, but it's okay one. Just follow me, and I only want two things from you. Number one, I need you to stay focused and concentrate. Try to listen what I'm trying to tell you. Number two, I want and I hope you can ask question if anything you're not sure. It's okay. If you're not sure, you don't understand, please ask question. Yeah, if you feel too shy to ask in the public space so that everyone can read your message, it's okay. You can DM me. Yeah, you can send me a private message. It's perfectly fine. Anything not sure, please ask. Yeah. All right. Come. Let's start. Okay. So let's look at what we learned in the previous lesson. Okay. So this is a substance. Assuming this, everyone, this is a substance. Let's say this substance is a solid. Now I want to do heating curve. So heating curve, I must do indirect heating. So here I put a beaker. So the beaker here, okay, my beaker a bit chacat, sorry. This beaker inside must have water. Okay, so guys, a quick self-test, a quick test for you. This is water. Okay, we call this thing as water bath. Okay, water bath, the level should be here, the blue color. Water bath, the level should be here, red color. Water bath, the level should be here, purple color. Which one? Which one should be the water level? Let me know in the chat box, everyone. We mentioned this last week. The water level should be where? 1, 2, or 3, everyone? Number 3, why? Because the water must fully cover the substance you want to heat. Because if the water only until here, which means only this part is being heated, you don't want. You want to heat all the substance, because remember, when we want to do heating, we want uniform heating. Okay, we want uniform heating, or we call even heating. Guys, what do we mean by even heating? Every single part, every single portion being heated. Okay, that is what we want. Yeah, that is what we want. Okay, all right. So we want uniform heating. Okay. So now let's come back to here. Okay. Okay. So in this case, okay, how to do the, okay, so that's why the water need to be here. Okay, because if the water level is here, the water cover the whole thing. So that's why the heating can happen here, 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 and here. Is okay? That's it. Okay. So when we do heating curve, remember, okay, on the top here, you must have a thermometer. Yeah. So thermometer help us to measure the temperature. Okay. Thermometer. Okay. So we know heating curve will look like this. First of all, when you heat the substance, normally we start the heating from room temperature. Normally, when you heat a substance or you cool down a substance, it's always from room temperature. Yeah, when you started to do heating, when you started to do cooling, normally it's from room temperature. Room temperature is how many, everyone? Room temperature, how much? Again, 1 minute revision. Room temperature, how much, everyone? Room temperature, 25. Is it okay? So that's why we start about 25. So that's why heating curve start around here, not starting here. This is 0. Heating curve not starting from 0, guys. Heating curve start from room temperature, which is 25. So around here, you start heating. You heat, heat. When you first heating, your solid become hotter and hotter, isn't it? Your solid become hot and more hot. Understand? But not melt, no melting yet. The solid not yet melt until the solid reaching the melting point. For example, let's say assume the melting point is 80. Let's say assume, don't memorize. At 80 degrees Celsius, the solid start to melt. So during the melting process, you see the temperature. This is temperature, everyone. This is temperature. Okay, and then this is the time. During the melting process, you will see the temperature just stay at 80 degrees Celsius. The temperature just stay at the same temperature without changing one. Okay, so during the melting process, the solid slowly melted so that you get more and more liquid. Okay, so remember, this is where the melting started. This is where the melting ended. So once the melting ended, all the solid already become liquid. All the solid already become liquid. Now this is liquid already. You continue to heat the liquid, so the temperature will continue to go up. Is it okay? The liquid will become hot and hotter, hot and hotter. So the liquid temperature continue to go up until you reaching your boiling point. For example, let's assume the boiling point is 145. Okay, some student will say, sir, boiling point not 100. No, boiling point 100 only for water. You don't think all substance boil at 100. Clear? Some student some student thought boiling confirm and always happen at 100 degrees Celsius. That is wrong. 100 degrees Celsius only for water. Okay? But did I say this is water? No, this is the substance that I didn't tell you what it is. So it is not a water. So the boiling point not necessary 100. So let's assume the boiling point is 145. Mr. Martin, should we memorize the number here, 80 and 145? Don't do that, please. Don't do that. So once you reach your boiling point, the liquid will start to boil. you will see bubble, bubble, more and more bubble. During the boiling process, temperature didn't change. It's okay. Temperature didn't change in the boiling process. So this is where the boiling process started. This is where the boiling process ended. So once the boiling process ended, all the liquid now become gases. So when you have gas, okay, now we have gases. When we heat the gas temperature continue to go up. So this is the heating curve that we have been learning for the last lesson. So I just want to show you so that you still remember. And please remember, the first horizontal line is melting process. The second horizontal line is where the boiling process take place. Okay, so this is what we learned in the past lesson. Okay, so today we will continue from here. So now we need to go deeper. We need to go deeper. What happened at here? What happened at here? What happened at here? What happened at here? And what happened at here? Because in the last lesson, we only learn or at here, what is it? Solid. At here, solid and liquid. At here, liquid. At here, liquid and gas. At here, gas. That's it. We only learn solid, liquid, and gases at different area, different region. But now today, we want to go deeper. We want to know what is happening. What is happening here? What is happening here? That's why I need you to pay attention, because this part is very, very important. This part is very, very important. Okay. And then it is always being tested in the examination. So I want you to stay focused. Okay. And then, like what I said, if you don't understand after I explain, please ask the question. Come, let's start. So you see, so now I put into 5 areas, A to B, B to C, C to D, D to E, and E to F. Okay, everyone, let's start with the simple one, A to B. So A to B is the part when you hit the solid, right? Because melting not started yet, right? So not melting not started yet. So everything should be in solid form. When you hit the solid, temperature go up. Why? Why when you hit solid, temperature go up? So now we need to know what happened. Everyone, you can see this is how the solid looks alike. See, solid. All right. Solid, they are looking, okay, they look solid, look like this. Solid look like this. Okay. So all the solid particles here, okay, all the solid particle here, they have their energy. Okay, guys, anyone can tell me what is the name of the energy for all these particles? Like today, when you have particle, what is the name of the energy inside the particle? What is the name? Anyone remember this? This is something you learn back in Form 2. Form 2. Okay, good. It's called kinetic energy. Okay, all the energy inside the particle, that is called kinetic energy. Is it okay? Example, today I have one particle. This particle can be an atom. This particle can be molecule. This particle can be ion. This particle inside got energy. This energy, we call it as kinetic energy. Okay? So you all have to be very careful because when you come to SPM, there are so many energy you will see, especially in physics. Physics, you will see electrical energy, potential energy, and so many other energies. Yeah? Right? So make sure everyone know all the particles here, they have kinetic energy. Okay. So let's assume these are the energy. Okay. This number don't memorize. Let's say we have all the solid have their energy. And guys, the solid, their energy not necessarily the same. The solid, their energy not necessarily the same. This one got 10 joule. Joule is the unit for energy. This fella got 12 joule. This fella got 11 joule. That's it. So don't think all the solid will have same amount of energy. No. Okay. The energy quite similar, more or less the same, but they not necessary to be equal the same. Just like 4 of us, we are good friends. It doesn't matter that our pocket must have same amount of money. True or not? Not to say, oh, we are good friend. I got 10 ringgit. You must have 10 ringgit. He must got 10 ringgit. She must got 10 ringgit. No, not necessary. We can be good friend in a way that I got 10 ringgit. You got 15 ringgit. Another fellow got 70 ringgit. Doesn't matter one. It's perfectly fine one. Yeah. So you can see, these are all the solid. They have 10 ringgit, 12 ringgit, 11 ringgit, 11 ringgit, 10 ringgit, 10 ringgit, 12 ringgit. It's okay one, okay? So all these we call kinetic energy. Okay, now what happened, guys? We are hitting the solid, right or not? Now we hit the solid. When you hit the solid, what happened? When you hit the solid, all the heat is absorbed. Okay, when you hit something, the heat is absorbed. The heat go in. Okay, so when the heat go in, what happened? Guys, look at here. This is the heat. Heat go inside, go inside, go inside, go inside, go inside, inside, and inside. So when the heat go inside, means I put more and more energy inside them. True not? Okay, I put heat is a form of energy. I put extra energy in you. I put extra energy in you. I put extra energy in you. So when we put energy in the particle, you can see the particle now got more energy. Am I right? See? 10 joule now become 15, for example. 11 joule maybe now become 17. Yeah, they will have more and more energy. Why they got more energy? They absorb the heat. They absorb the heat. They get extra energy from the heat. Okay, you can imagine heat is somebody who give money. You have 10 ringgit, I give you some extra money. I give you some extra money. I give you extra money. I give everyone extra money. So now everyone got richer. Everyone got richer. Everyone got more money now. So now what happened? So the kinetic energy now increases. Am I right? The kinetic energy is getting more and more now. So when kinetic energy increases, what happened? Okay, guys, I want all of you to learn a concept today. Kinetic energy got a best brother or best buddy, or we call twins. There is a twins. Okay, the twins is kinetic energy and temperature. I want all of you to know kinetic energy and temperature, they are twins. When I say they are twins, means what? They always do the same thing. So if kinetic energy increases, temperature will follow, increases as well. If kinetic energy decreases, temperature follow, decreases as well. If kinetic energy didn't change, temperature also didn't change. So please remember this. Kinetic energy and the temperature, they are twins. They do the same thing. So in this case, what happened to the kinetic energy, everyone? Increases. So why kinetic energy increases? We absorb the heat, right or not? The heat coming in, we get extra energy from other places. So when particle absorb the heat, particle got more and more kinetic energy. When kinetic energy increases, temperature increases as well. Okay? So how to put in words? If the question say, if the question say, student, can you please explain, okay, what is happening, okay, during A to B here. So how are you going to change all the picture I drawn just now? How are you going to change all the picture that I drew just now to become some words or paragraph, or we call sentences? It's like this, you see? From A to B, all the heat absorbed by solid particle. The heat absorbed by solid particle. Right? Why solid? Because melting not starting yet, matter not. Melting not started yet. Everything is solid. So all the heat absorbed by solid. Okay, so like this, these are the particle. This is the solid. This solid get extra energy from the heat. So when the solid got heat, the kinetic energy increases. When kinetic energy increases, temperature follow the same thing. Temperature increases as well. Okay, guys, let me know in the chat box, are you okay how to explain what is happening in A to B? Are you okay? Are you okay with how to explain the process A to B? So I don't want you to memorize the long, boring, nonsense sentences. I don't want. I really hope that if you really want to memorize anything, memorize this picture. Because when you have this picture in your mind, when you can imagine what is going on, you can write the answer yourself. You can create the answer yourself. So don't memorize everything, because a lot of students, they always want to be robot one. They want to memorize everything. Don't do that. Yeah. Okay. So that's the first thing. Okay. Now the second part, this is much, much, much more important now. Okay. This is much, much, much more important. Now, process B to C. Okay. This is very, very important. So as you all can see, B to C is the melting process. During the melting process, can you see the temperature didn't change? Am I right? The temperature here, they didn't change. So didn't change, sometimes they can call constant. The temperature remain constant. Or sometimes they say unchanged. Yeah. So during the melting process, the temperature didn't change. Why? Why the temperature didn't change? This is very, very, very popular question in SPM. They love it. They always ask this question. Why temperature didn't change during melting? Why temperature didn't change during boiling? They love it. So let me show you how it works. Okay, melting. So let's look at what happened during melting here. So I want everyone to imagine. Same thing. I want everyone to imagine. Okay. So now we know process B to C. We want to do a melting process. So guys, melting process, what we did, we want to change solid. Okay. For melting process, we want to change solid all the way to become liquid. We want to change the solid all the way to become liquid. That is what we want to do. Okay. So what happened? What happened during this process? What happened during this melting process? Yeah. So we need to know what is happening here. Okay. So solid look like this. You want to be liquid, it will be like this, isn't it? Okay. So guys, now listen. So all these solid, they have energy, right? Okay. Let's say 11 joule, 10 joule, 10 joule, 11, 12, 11, let's say 10, 10, 12, for example. Don't memorize that. So all these particles, they have energies. All right, this energy called kinetic energy. So now what happened? Now, when you want to change the solid to liquid, you need to do this. This is solid. They holding hand with another solid. So when they holding hand, which means they sticking together like this. Now, when you want to change the solid to become liquid, you see, liquid, you want to break them apart. Am I right? See, you want to break them apart. So you want to break them apart. So if you want to break them apart, you need to use some you need to use the energy to help you, because you see, when two people holding their hand tightly, okay, when two people holding their hand tightly, you need them to get, you want to separate them, you need something to help you. So what is the something here? You can use the heat. Okay, because you see, when we want to melt a solid, okay, when the heat you absorb can help you. Why? The heat here, you can use this heat to become a knife. You use the heat as a knife to cut them apart. Okay? You use the heat to cut them apart. So you see, imagine. Now I want to do melting. During melting, I absorb the heat. All the heat that I absorb, I use the heat as a knife to cut, 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 cut. I use all the heat to cut them apart. Why I want to cut them? Because if you don't cut the solid, you don't get the liquid. Okay? So now, after I use the heat to cut all this thing, do you still have any heat? No, no more. All the heat that you have, you use it already. Okay? All the heat that we have, we use all of them already. Okay? Just like, okay, I got this heat, imagine is money. I got $700. This $700, I use it to cut. So now all the $700 gone, no more. So when you have no more extra money, do you think that you can give the heat to the particle? Do you think that money can go inside the particle now? Yes or no? Yes or no, everyone? Just let me know yes or no. Can the heat go into the particle now? Yes or no? Can the heat go into the particle? Yes or no? Just let me know yes or no. What about the rest? Guys, what about the rest? Are you guys okay with it? Just let me know yes or no. Do you think the heat can go inside the particle? Yes or no? No, cannot. Why? Because all the heat, you use it, you use all the heat to cut. You use all the heat. You use all your money already. When you use all your money, do you still have money to give people inside? Don't have lah. Cannot lah. Okay? So now no more money. So now you don't have money to give the people already. When you don't have money to give the people, all this kinetic energy, they will change or not? No change, true not? Or I have 11 ringgit, I'm still have 11 ringgit now because I don't get extra money from you. Okay, I don't get extra money from you. So now all the kinetic energy is the same. So when the kinetic energy is the same, the temperature will follow the same. Am I right? Because kinetic energy and temperature is the sibling, or we call the twins. So when kinetic energy no change, you can expect the temperature also no change. So that is what I want you to know. All right. So not very hard. How to put in words, everyone? Put your eyes on here. You see, learn how to write this. Learn how to write this, please. Okay. So in the process B to C, where is B to C, everyone? B to C is here. So B to C, this is where the melting process taking place. So B to C, melting take place. So during the melting process, what happened? All the heat absorbed, all the heat that we put inside, all the heat they absorb, they use the heat. Where they use the heat? Overcome force of attraction. Guys, what do we mean by overcome force of attraction? Overcome force of attraction means cut. Okay, like solid, solid want to become liquid, I must cut. This cutting process is called overcome force of attraction. So you use all the heat, to overcome the force of attraction. When you use all the heat already, no heat can go inside the particle, right? Cannot. No heat can go inside particle. So the particle kinetic energy remain unchanged. When the kinetic energy didn't change, the temperature also didn't change. All right. So let me know in the chat box, are you okay with how to explain process B to C? Are you okay how to explain this? Are you okay with how to explain process B to C? So I hope you all can see this. This is why the temperature didn't change, okay? Because, all right, all the solid here, they have energy, okay? 10, 10, 11, 11, 12, 11, 10, 10, 11, for example. So now when you absorb the heat, now the heat didn't go inside the particle. Why? Because when you want to do melting, you want to do some cutting. So to do the cutting, we use the heat. So now the heat, we use it to be the knife to cut. When you use all the heat to do the cutting process, so there's no more heat already. All the heat no more. So no more heat, you cannot put the heat inside the particle. So when you cannot put the heat inside the particle, the kinetic energy of the particle didn't change. This is cross, didn't change. When kinetic energy didn't change, the temperature also didn't change. So that's why I really hope you all can imagine, I really hope you all can understand what is happening rather than memorize answer. Because many students, they can write a perfect answer, but they not even know what they are writing. A lot of students like this, they score very well, but they not even know what they are writing at all. But they're damn good with memorizing answer. They're damn good with memorizing answer. Okay. I not advise you to do that lah. I not advise you to do that. Yeah. All right. Because if you go for higher level, you will suffer one. Because if you don't have the understanding, you only know how to memorize answer. Uh, you will suffer lah somehow. Okay. All right. Finish, huh? So now settle already. Okay. So now the same thing. Okay. So the same thing happened to C to D. C to D, what happened? C to D. C to D is the melting completed. You see, after you melt the substance already, all the solid already become liquid. Okay, so now when you have a liquid, you continue to heat the liquid. So when you continue to heat the liquid, what happened now? Okay, so this is liquid. All right. So when you heat the liquid, do you need to cut them? No, no need, because the boiling not started yet. I didn't do boiling yet. Okay, I only heat the liquid ma. I didn't start the boiling yet. So when you didn't do the boiling, you don't need to cut ma, because boiling need to cut to become gas ma, isn't it? But now I am not doing boiling yet. So when you are not doing boiling, what happened to the heat? All the heat now, do you need to do the cutting? No need. You don't need to do the cutting. So when the heat no need to do the cutting, where the heat will go? The heat will go inside the particle again. So when the heat go inside the particle, so what happened to the energy? The kinetic energy will increase. When kinetic energy increase, temperature will do the same thing, increase as well, because kinetic energy and temperature, they are twins. They do the same thing. That's why you all can see from here, process C to D. Can you see that the temperature keep increasing again, go up again? That is what happened. Why? Your liquid absorbing the heat. When liquid absorb the heat, okay, liquid got more and more kinetic energy. When liquid got more and more energy, liquid temperature increases. Okay? So the idea very simple one. When you want to do cutting, then the heat cannot go inside the particle. When you didn't do the cutting, the heat go inside the particle. So why in this case we don't need to do the cutting? Because we are not doing boiling yet, isn't it? We didn't do boiling yet. Okay, I just heat the liquid only. I didn't boil the liquid yet. So that's why I don't need to do any cutting. When you don't need to do cutting, all the heat go inside the particle. Like guys, let me know in the chat box, are you okay with what is happening on the process C to D? Are you okay with what is happening from the process C to D? Okay, can okay, now let's do the last thing, then we will end with the heating curve. Okay, the last thing here, D to E. So D to E, what happened, everyone? Boiling. So the boiling process is taking place. And you all can see during the boiling process, what happened to temperature? The temperature didn't change, right or not? The temperature didn't change during the boiling process. Why? So same thing. So same logic. Why during the boiling process, temperature didn't change? So now let's think in this way. Boiling. So guys, what boiling do? Boiling help us to convert liquid to gas, isn't it? Boiling helping us to convert liquid to gas. So when liquid convert to gas, what happened? This is liquid, right? Something sticking together, and the gas will be something like this, okay? Or maybe only two things sticking together. It's okay, all right? Don't I told before, gas not necessarily come alone one. Gas can be like two things stick together, but they are very far apart like this. It's okay one, all right? So guys, same thing. If you want to change liquid to gas, what you want to do? You want to do cutting. Am I right or not? You must cut, only can get this ma. This cutting process, how to do that? To cut the things, you need to use a knife. Okay, this knife is the heat. Am I right? You need to use the heat to cut, 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 cut it. So when you use all the heat to do cutting, okay, can the heat entering the particle? Yes or no? Yes or no, everyone? Yes or no? When you use the heat to do cutting, do you think that the heat can go inside the particle? Yes or no? No, true not, right? Because all the heat you use already, you use all the heat to do cutting. When you use all the heat, no more already, So no more heat. How can heat go inside the particle? Am I right? Cannot. So when the heat didn't go inside the particle, their energy got changed or not? No change, So the particle, the energy, no change. What is the name of the energy? Kinetic energy, isn't it? So the kinetic energy didn't change. When kinetic energy didn't change, temperature also didn't change. Why? Because I told you early on today, kinetic energy and temperature, they are twins. They are siblings. Whatever thing happen to kinetic energy, the same things will happen to the temperature. Okay? So the answer will look like this. If you look at the answer, all right, what happened? D to E, boiling take place. So during boiling, all the heat absorbed is used to, now learn this word, overcome the force of attraction. Overcome force of attraction means cutting. You cannot use the word cut. You have to write overcome force of attraction. Some of the students, they want to use the word break bond. They say all the heat absorbed is used to break the bond between liquid particle. Cannot. In SPM, they don't allow you to use the word break bond. In this case, cannot. If you write break bond, no mark at all. So you cannot write break bond. You cannot write cut. You must write overcome. Okay? Force of attraction. If you don't want to say if you don't want to say force of attraction, you can say overcome attraction force. Also can what? No problem. You can write force of attraction or you can write attraction force. It's perfectly fine. So all the heat that we absorb, all the heat that we absorb, we use it to overcome the force of attraction between liquid particle. Okay, why the force of attraction is between liquid particle? You see, boiling, what we do? Boiling cut the liquid in order to become gas, so you cut the liquid. So this force of attraction is between liquid particles. Okay. So when you use all the heat to do cutting, no heat can go inside the particle. So particle kinetic energy didn't change. Particle, the temperature also didn't change. That's it. So I really hope you all understand what I am trying to explain over here. It's not hard. If you notice, the explanation here is very similar to here, only change a few words. You see, look at it. What I changed just now is melting. Now I change to boiling. So boiling, what you do, you absorb the heat to cut the liquid thrown out. You see, melting, you want to cut the solid, cut the solid, you will get liquid, boiling, you want to cut the liquid in order to get the gas. Can you see that? The answer is the same. Okay, for melting and boiling, you only change a few keywords only. Just change a few keywords. Because some students say, sir, very hard lah, very confusing lah. I need to memorize two answer here. Who asked you to memorize the answer? Who asked you to memorize the answer? You don't need to memorize the answer, right? And if you really want to memorize, you don't need to memorize both. If you really want to memorize, you memorize only one answer. You can modify this answer to make it become boiling. So always remember, okay? Learn hard, of course, is important. It's important to be hardworking, but you must know how to learn smart. You must know how to learn smart as well. So many students love to memorize all these things. So some students, when they look at it, oh my God, they memorize all the answer here. No need to memorize all the answer here. That's what I told you just now. Don't memorize the long, boring sentences. Okay? Just look at the picture. Use the picture that I show you just now and imagine what is going on. When you can imagine what is going on, you can create, you can goreng your own answer. You can really goreng your own answer if you can imagine what is going on. Okay? All right, guys. With that being said, we are all done with heating curve. Finish ready? Okay? We finish everything on heating curve already. Yeah? I hope you guys understand what I'm talking about. Okay. So if there is any part you're not so sure, feel free to ask. Okay. So now let's do some exercises. Okay. Let's do some exercises together before we do cooling curve. Okay. So guys, I emphasized and I told you previously why doing exercises is so important. Yeah. Because I think I told you all since the first lesson, you guys coming from a special batch. Okay. So your batch is called examless batch. No exam one. Yeah. You don't have a proper UPSR exam, you don't have a proper PT3 exam. So, and then that is a big issue, all right? Many students don't like exam. A lot of people don't like exam. Okay, but exam is there for a reason. Exam is there to evaluate, or we call to do assessment, so that you know your performance. Exam will tell you your learning process. You understand or you don't understand those concept or knowledge. Yeah. So, but when you don't have all these exam, so that's a problem for many students. Okay, they don't know what they understand, they don't know what they don't understand, so that is a very big issue. So that's why what we need to do is that you have to do question, because only by doing this question, then you will know what kind of question you capable to do and what kind of question you couldn't do. Then from there you will understand your strength and your weakness. So this is very important. Come, let's start. Okay. So I told you before, if you really want to do question, don't waste your time to do the question from reference book. Okay. Don't waste your time to do the question from textbook. Don't get me wrong. I am not against reference book. I'm not against textbook. The thing is, reference book and textbook questions sometimes the standard not the same as SPM. They can be too easy, they can be too hard. So no point, really no point. Okay. Uh, so the best one, if you really want to do the question which have same standard as your SPM, which is trial exam paper, which you can get it easily from internet, okay, from online resources. There's a lot, and also a past year paper or past year question. These are good quality questions that you should practice on. Then a lot of people say, sir, is it too early for us to do this by Form 4? No, no. All right. The earlier you start, the better it is. The earlier you start, the better it is. Okay. All right. Because I want you all to understand one thing first. Okay. I really want you all to aware one thing. Your batch, for your batch, Form 4 this year, your foundation and your fundamental is quite weak compared to previous few batches, compared to your seniors. Yeah. That's why you have to start doing exercises as soon as possible. Okay. To strengthen your understanding. Yeah. Okay, come, let's start. Okay, this is the first question. This question is coming from Selangor, 2023 Selangor trial exam paper. So the question say, this diagram shows the apparatus setup to determine the melting point. This melting point is naphthalene. Okay, so everyone should know this picture, isn't it? This is a heating curve. This is a indirect heating. Why? Bunsen burner heat the water, eventually the water hit the substance. Yeah, all right. So first question, what do we mean by melting point? What is melting point? So guys, I told you all previously, right, in the past lesson, what is melting point? Melting point is not a point, right? Melting point is a constant temperature. Melting point is a constant temperature. Why we need to put the word constant? During melting, during the melting process, the temperature didn't change. Okay, so melting point is a constant temperature. And what happened during melting? Solid change to liquid. So when solid change to liquid, so there is another important thing we need to write here. Anyone remember what it is? Anyone remember what it is? Melting point is a constant temperature where solid change to liquid. There are a few more things we need to write here. Anyone remember what it is? At a specific pressure. At a specific pressure. So you need to mention about pressure. Okay? So please, if you forgot to write the pressure here, you only write melting point is a temperature where solid change to liquid. You got 0. No mark at all. Okay? So please, this is something I mentioned last week. I hope you still remember. I mentioned this last week already. Yeah? Melting point is a constant temperature where solid change to liquid at a specific pressure. If you don't want to say specific pressure, you can say at a particular pressure. You can use the word particular or specific. They are the same. Yeah, no problem. So I hope everyone know what is melting point. Okay, what is the definition of melting point? So remember, I told you what is the common mistake for student. Student will write melting point is a point where solid change to liquid. No, don't do that. Yeah. So make sure everyone know what is melting point. So if the question asks what is boiling point, same thing lah. Boiling point is a constant temperature where liquid change to gas at a specific pressure. Okay. So I hope everyone know what is the definition for melting point. Definition means meaning lah. Okay, guys, let me know in the chat box, please. Are you okay with the definition of melting point? Yes or no? Are you okay with how to write the proper definition for a melting point? Yes or no? Let me know in the chat box. Okay. So it's not hard, but you all have to be very careful because many students lose the mark just because of careless mistake. Forgot to write pressure lah, no mark. Forgot to write constant lah, no mark. Understand? So you must be very, very careful and you must be very attentive to small details. So you have to be very careful with some small details. Yeah? All right. Next one. Okay. What is the type of particle found in naphthalene? All right, guys. When I say particle, what is it? Atom, molecule, or ion. So guys, you try. Let me know. Naphthalene, solid, liquid, or sorry, not solid liquid. Sorry. Atom, molecule, or ion. Just type the letter A, M, or I. You think naphthalene is an atom, naphthalene is a molecule, or naphthalene is an ion? Okay, very good, guys. Fantastic. Naphthalene is a molecule. Why? 1 minute revision, everyone. 1 minute revision. Atom is somebody who is alone. When this fellow alone, they don't combine with other people, they don't have any friends, they are atom. So molecule is what? Non-metal combined with non-metal. When you take non-metal combined with another non-metal, you got molecule. What is ion? Ion is somebody that got charged, okay? Or somebody made of metal and non-metal, okay? So make sure everyone know how to differentiate atom, molecule, and ion. This is what we learned in the first lesson. All right, this is what we learned since the first lesson. So let's do it. So in this case, naphthalene, how to know it is an atom, molecule, or ion? So look at the formula here. So they told you naphthalene is C10H8. So naphthalene is made from 10 carbon. Carbon is non-metal. Naphthalene is also made of 8 hydrogen. Hydrogen, common sense. Hydrogen also a non-metal. So when non-metal and non-metal join together, you're going to get a molecule, isn't it? When non-metal join together, you are getting a molecule. Next one. What is the physical state of naphthalene at room temperature? When you see the word state, it means solid, liquid, or gas. How to know the naphthalene is a solid, is a liquid, or is a gas? Just look at this thing, okay? I teach you 2 ways to see. Number 1, when you see the word melting point. So melting point means what? You start with a solid matter, not. You must have a solid, you heat the solid and make it become liquid. That is the melting point. So I know already this is a solid. Second thing, when you have a liquid, okay, you see, normally liquid, they draw like this. They draw with some dotted line like this. So if you see, they only draw like this whole thing without label, or sometimes they draw the solid, like they put like this, like powder, or they draw like this. These are all solid. It's okay? Liquid must have some dotted line like this. Okay? So from this one, you can see this thing obviously looks like what? Powder, right? Do not look like powder. So it is a solid. Okay? So from here, you should know that this fella is a solid. This fella is a solid. All right, finish. Okay, next one. What is the purpose of using water bath? Okay, you let me know in the chat box, guys. Short answer. Why we use water bath? Short answer. Don't need to give me a full sentence. Short answer in point form. Why we use water bath? Why we use water bath, everyone? Come on, guys. Let me know in the chat box. Why we use water bath? Uniform heating. You can use the word uniform heating, or you can use the word even heating. Yeah, you can use the word uniform heating or even heating. But try to put in a more proper sentence. Okay, to ensure uniform heating, to ensure even heating. You heat what? You want to heat what? Naphthalene. Okay. If you only say to ensure uniform heating, they don't know what you are heating. They don't know what you are heating. So please tell them, I am heating the naphthalene. I am heating the naphthalene. So to ensure uniform heating of naphthalene. Yeah. So the answer that you give, try to make it as detailed as possible. Yeah. Try to make it as detailed as possible. All right. So if you can do this question in Selangor 2023 trial exam paper, you able to score 4 marks here. That's it. Yeah. I don't think this 4 mark is too hard to score. I think this 4 mark is quite easy. All right. So next one. Okay. All right. So this question is still the same. Continuation A, B, C, D. So now it's the same question. This is question E. So now the question give you a graph. The question give you a graph. They say this is the experiment result has been recorded, and this is the graph of temperature against time. So guys, when you see a graph got temperature, got time, it must be heating curve or cooling curve. How you know this is heating curve or cooling curve? Look at the staircase. The staircase is going up, right? So it's heating curve. If the staircase is coming down, it's cooling curve. So this is a heating curve. So I knew this is a heating curve. So the question asks, why there is no change in temperature from B to C? So B to C is here. Okay, why the temperature didn't change? Okay, so I told you, right, this is a very popular question. They always love you. So they always ask you, why melting temperature didn't change? Why during melting temperature didn't change? Why during boiling temperature didn't change? They love to ask that. Yeah. All right. So guys, how to know this process is a melting or boiling? Okay. So if you read back the question, they say what? This entire question just now, they say melting point, right? Melting point. So you know already this question should be melting. Yeah. All right. So now, why during the melting process, temperature didn't change? So don't memorize the long, boring answer. True not? Okay. Remember, I told you just now what happened. During melting, what happened? This is the solid. Solid want to change to liquid. Solid want to change to liquid. When solid want to change to liquid, need to do cutting, 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 cutting. How to do the cutting? Use a knife. The knife is the heat. So we absorb the heat and use the heat to cut, 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 cut. When we use all the heat to do cutting, no more heat already. So when no more heat, the heat didn't enter the particle. When the heat didn't go into the particle. When the heat didn't enter the particle, the kinetic energy didn't change. When kinetic energy didn't change, temperature didn't change. Okay? So now let's look at the answer. All right, let's look at the answer. Okay. So this is the answer. Okay. All the heat absorbed is used to overcome the force of attraction between particles. So you see, I saw a few students type the answer in the chat box. Very good. Okay, to name it, Hui Xian, Daniel. Yeah, very good. Okay, good effort to put the answer in the chat box. But be careful. Okay, you need to write the word all the heat. All the heat energy absorbed. You must write all. Because if you only say the heat energy absorbed is used to overcome force of attraction, which means what? Maybe you only use some of the heat that you absorb. No, cannot. We are using all the heat that we absorb. Okay, all the heat that we absorb, we use all of them. So that's why you need to put these words, all the heat energy absorbed. Mr. Martin, if I don't want to write the word heat energy absorbed, I only want to write all the heat absorbed. Can or cannot? No problem. No problem. Okay? All the heat absorbed is used to overcome. Overcome what? Overcome force of attraction. This force of attraction is between what? Okay? Is between what? Guys, I am doing melting. So melting, who is joining together, guys? Melting, who is sticking together? Solid, right? So it's better to write, okay, all the heat energy used to overcome the force of attraction between solid particles. That would be a best answer. Okay, guys, let me know in the chat box. Are you okay with how to explain this? Are you okay with how to explain this thing? Let me know in the chat box. Yes or no? Just let me know yes or no. Are you okay with how to explain? Okay. And then do you notice that? Do you notice that? Okay. They are very particular on the detail. So if you don't write the word all here, maybe you will lose your mark. Depends on examiner. Some examiner who are very strict, who are very particular, they will give you the whole thing wrong. Understand? Just because you didn't write the word all, just because you didn't write the word all, you lose all the mark. So please be very careful. All the heat absorbed is used to overcome force of attraction between solid particles. Okay, finish. All right. So that's the first question. Okay, let's try another one more. The next question, this is coming from Johor. This is Johor question. Okay. JUJ. JUJ is a short form for a paper like JUJ. J is called Jaya untuk Johor. Yeah, they call it Jaya untuk Johor lah. Okay. So Johor paper 2023. They give you this picture. Everyone can see left hand side picture. Obviously, this is the experiment for heating curve. True not? This is heating process. So of course, this is heating curve and makes sense. This is a heating curve. How I know? Staircase going up. All right. So the first question is asking me, what is the particle in naphthalene? Quite easy. True not? So naphthalene, you see, naphthalene, the formula, naphthalene, this is the name. The formula is here. All right. C10H8. Okay. All right. Yeah, Hui Xian say naphthalene again. You are right, Hui Xian. Okay. Sometimes, it's like they have nothing to ask, right? No. When they ask heating curve, 99.9999% is naphthalene. You see, everyone look at here. Naphthalene. Okay. This okay? This one no? Naphthalene. Naphthalene. You see that? Right? They love naphthalene so much. I don't know why. I don't know why. Yeah. They always ask naphthalene one most of the time. Okay. All right. So guys, now what is the particle? Easy lah. Naphthalene made from carbon and hydrogen. Carbon is non-metal. Hydrogen also non-metal. Non-metal join together molecule. Yeah. So you know already. Naphthalene supposed to be a molecule. Naphthalene, it is molecule. Next one, you need to explain why the temperature become constant. Constant means no change from T1 to T2. So where is T1 to T2, everyone? T1 to T2 is here. T1 to T2, it's here. So you know this process is melting process. Why we know this is melting process? Because obviously, you see, this question, all right, they started with a solid. So when you have a solid, they heat it, it will be a boiling process. Sorry, melting process. It is a melting process. Sorry, my bad. I say boiling just now accidentally. Should be melting. Yeah. All right. So why during the melting process temperature is constant? Same thing lah, right? Melting. All the heat that we absorb all the heat that we absorb used to cut. This cutting is called overcome force of attraction. So where is the force of attraction, everyone? Melting, you are cutting what? Cutting solid. Force of attraction between solid particles. And add one more word. This heat that we take in called heat absorb. Okay? So all the heat that you take in, you use to do cutting up. Every single heat you take in, you use to cut it. So you have to put the word all. All the heat absorbed is used to overcome force of attraction between solid particle. Yeah, that's it. All right. So that is how it works. Okay. All the heat absorbed is used to overcome the force of attraction between the particle. Yeah. Okay. So I get a question in the chat box. In exam, can we write point form? Not advisable. Okay. Not advisable. Okay. You have this. You have two part. Later you will see one. You will have structure. Okay. For your paper two, you will learn this later on. Paper two, you have structure question as well as essay question. Structure question, don't use point form at all. Don't write point form. Always put your answer in a proper sentence. For essay question, if you want to write in point form, is perfectly fine. No problem. I will guide you more on this later on. All right. So for now, when we first started with Form 4, I not advise you to use point form. So try to put the answer in a proper sentence. Yeah. All right. So next one. During the heating of naphthalene. Why naphthalene is not heated directly using Bunsen burner? This is a very interesting one. Why naphthalene you don't heat it directly? So guys, for your information, this is extra knowledge. Naphthalene is called mothball. Okay, you can Google mothball. What is it? So mothball is a white color ball. Normally in daily life, we put it in the we put it in those like wardrobe to get rid of cockroach. Yeah, because naphthalene will undergo sublimation. So when naphthalene undergoes sublimation, the solid naphthalene will release some gases. So the gas release got some smell that cockroach or insect, they don't like it. So mothball, or we call naphthalene, can help us to get rid of cockroach. That's it. So guys, why we cannot take the naphthalene and put under Bunsen burner directly? The reason is this. Naphthalene is highly flammable. Highly flammable means very easy to catch fire. So if you directly put the naphthalene right under the fire, the naphthalene will catch fire. Very dangerous. That's why we do indirect heating. That's why naphthalene, you put in a tube and then we use water bath or oil bath or sand bath to heat it. Okay. So the main reason why we don't heat naphthalene directly, okay, why we don't heat the naphthalene directly under the Bunsen burner is because it is very, very volatile. Okay, naphthalene, it's a very volatile, sorry, not volatile, sorry, it's a very flammable compound. It's a very flammable compound. Okay, so I hope everyone know what do we mean by flammable. They catch fire easily. Yeah, they burn very easily. Okay, guys, let me know in the chat box. Are you okay with this? Are you okay with this? Why we didn't take the naphthalene and directly heat under the Bunsen burner? Are you okay with this? Okay, can okay, good. So now we are done with this question. Okay, this question is done. Okay, we have a few more questions to go. All right, I think we have two more. Yeah. Yeah, three more. Yeah, three more questions. Let's finish it for in the next 10 to 15 minutes. Then we move on and learn something new today. Okay, next one. This is MRSM trial exam paper. So guys, MRSM, the paper is fantastic. Okay, you see, all right. Again, I only can comment for the subject chemistry. Other subject, I don't know. If you look at chemistry, among those trial exam paper. If you look at chemistry, among trial exam paper, the hardest one, champion, is always MRSM. MRSM, their paper, the question is fantastic. When I say fantastic means what? The questions is very challenging. It's good. So, and most of the time, MRSM paper is even harder than SPM paper. So I always tell my students, if you practice using MRSM paper, and if you can do MRSM paper, it is very unlikely that you cannot do SPM paper. Very unlikely. Why? Because MRSM paper generally is harder than SPM paper. Yeah, you can do MRSM paper. Most likely, you shouldn't have any problem to do your SPM paper as well. Second one is SPP. So SPP is the boarding school lah, Sekolah Berasrama Penuh. Sekolah Berasrama Penuh. Okay. Then after that, this Penang paper is considered a very good paper one. Selangor paper is good. And then we have Negeri Sembilan. Okay. So these are some good trial exam paper. Okay. For chemistry lah. Okay. These few papers are very, very, challenging. Okay. Which is a good practice for a student. Okay. Anyway, come back to here, everyone. So this MRSM paper, they give you this graph, temperature versus time, staircase. You all know already. This is a heating curve. How you know his heating curve? Temperature go up, right? So it's a heating curve. So they say this heating curve is used to find melting point. So you know already this process is melting process, isn't it? Because they say melting point. Okay, first one. What is the meaning of melting point? That is easy, right? Melting point is a constant temperature. So solid change to liquid at a specific pressure. Please allow me to remind you all one more time. You need to write specific pressure. Don't forget to write the pressure. Okay. I always say it is very, very fair one. It is always very fair one. If you forget to write the pressure, the examiner will forget to give you the mark. Understand? You forget, they forget. You forget to write, they forget to give you the mark. So you will get 0. So please be very, very careful with that. Yeah. Next one. What is the melting point for substance Z? So what is melting point? Melting point is the temperature which you melt lah. So this is the melting process. How to know what is the temperature for melting? So this horizontal line, you go and read here, 78 lah. Okay. So if you write 78, no marks at all. Why? You didn't write the unit. Understand? You need to write the unit. Okay. If you only write 78 without the unit, no mark at all. So as a science student, not only for chemistry, including physics, including biology, you always need to put unit. Because if you don't put unit, I don't know what you're talking about, isn't it? For example, if you ask me, sir, what is the height of the building? You only say, oh, the building is 40. 40 what? 40 meter, 40 cm, 40 feet, 40 inches. So not, I don't know. You only say 40. I don't know what you're talking about. So you must tell me the unit. Okay. So unit is important, guys. Don't forget about the units. All right. Okay. Next one. Okay. Draw the arrangement for particle for substance Z from A to B. So when they give you these kind of boxes, you know already you need to draw solid, liquid, or gases. How to know it is solid, liquid, or gases? They want point A to B. So everyone put your eyes on here, A to B. Can you guys tell me here, A to B? Just tell me A to B is a solid, liquid, or gas. A to B, solid, liquid, or gas, everyone? Solid, right or not? Okay, melting is here, So this one, no melting yet, not yet melting. Solid, lo. So how to draw solid, guys? Remember I told you all, we are more strict in SPM on how to draw your solid, how to draw your liquid, how to draw your gas. When you want to draw your solid, you must make sure that the box must be full. I don't want to see empty spaces in the box. Number 2, you must draw minimum 3 times 3. So minimum 3 rows, minimum 3 column. I say minimum. So if you want to draw more than 3 times 3, it's perfectly fine. Okay? But don't go lesser. Minimum 3 times 3. So your answer might look like this. This is how it looks alike. Yeah? All right. Next one. The temperature B to C is constant. Why? Why temperature didn't change? B to C, what is it? So B to C is here, melting. Why during melting, the heat didn't change? Melting, all the heat absorbed used to cut the solid particle. When you use all the heat to cut the particle, no heat can enter the particle. So the particle, the kinetic energy didn't change. When the kinetic energy didn't change, so the temperature won't change. So you can write like this. And guys, to be honest, do you agree with me that this question they always ask, yes or no? Do you agree with me that they always ask this question, yes or no? You see that, right or not? We have done about 3 questions. Almost every questions that we covered, they have this question. Almost every question that we covered so far, they ask this question. Okay? So this is a very, very popular question. They love it. They love it. They always ask you why temperature is constant, why temperature didn't change during the melting process, during the boiling process. Yeah? So same thing, guys. How to make my answer is better here. Okay, because melting, you want to cut the solid particle. So better you put a word solid. Okay. All right, but even you don't put the solid here, normally they won't penalize you. Normally they won't deduct your mark. Even you don't put the word solid there. They are okay one. Yeah? All right. Next one. This is a question from Negeri Sembilan. Okay, 2023, Negeri Sembilan. The diagram shows a graph of temperature against time to heat. Oh my God. Naphthalene again. See that? Naphthalene again. Right, first one. What is the particle for naphthalene? You know lah, molecule. Naphthalene is a molecule. Okay. All right. So next one. Based on this picture, tell me the melting point for naphthalene. So naphthalene melting happened at here, horizontal line. The temperature here is 80. Don't forget the unit, degree Celsius. Yeah. So it's supposed to be 80 degree Celsius. Okay. Next one. Why there is no increase in temperature from P to Q? So P to Q, the temperature didn't increase. Yeah, not only didn't increase, didn't decrease as well. Why? The temperature didn't change. See, very popular question again. Why the temperature didn't change? Okay, why the temperature didn't change? So the same popular question come all over again. So you know that why temperature didn't change? All the heat absorbed is used to overcome force of attraction. Yeah. So you see, this question we see 4 times already. 4 times already. Just for the question here. Almost every question they ask this. Almost every question they ask this. Last one. Last question. All right. Diagram 6.3 shows the picture. Diagram 6.3 show a picture to find melting point for naphthalene. Again, it's naphthalene again, yeah? All right. So this question, everyone. Now, inside the beaker here, they put 2 liquid. One liquid, the boiling point is 78.5. Another one liquid is 100. So now what we want, this question want us to ask. So this question asks us, what is the suitable material? Okay, what is the suitable material to be used? Okay, what is a suitable material that we can use here? Okay, all right, to put in a beaker. Give one reason. Okay, guys, this is naphthalene. Just now, if you all can see naphthalene, what is the melting point? 80, right? Naphthalene, the melting point is 80, which means we need to heat until 80 degrees Celsius. Naphthalene, we need to heat until 80 degrees Celsius. So when you want to heat until 80 degrees Celsius, this liquid that you put inside here, can it be 78.5? Yes or no? Can it be 78.5? Yes or no? Yes or no? Cannot, am I right? Why? Because if this liquid, the boiling point is 78.5, which means what? When you heat until 78.5, all the liquid boil. When the liquid boil, they become gas. Gas run away, run away, run away, run away. So when the liquid become gas, the liquid become lesser, 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 lesser. The liquid will dry out. Do you want the liquid to dry? No, you don't want that. Okay? When you use water bath, oil bath, you don't want the liquid to dry. Cannot. Yeah. So that's why in this case, what is the most suitable one? You choose substance Y. Substance Y, the boiling point is 100. So only 100 only boil. But now do you heat until 100? No. Naphthalene, you heat until 80 degrees Celsius only. Then it melts. So when you heat until 80, the liquid not boiling yet. When the liquid not boiling, so no problem lah. You don't need to worry because they won't dry up. They won't become dry. They won't become gas and run away. So how to put in a proper sentence? You see, they give you 2 marks for this question. They give us 2 marks. They ask which substance is suitable. You just mentioned substance Y. You get 1 mark. And you just mentioned substance Y. Mr. Martin, if I don't write the word substance, I just write Y. Can or cannot? Can. Yeah. You can put Y and full stop. It's okay. 1 mark. So give a reason why we choose substance Y. Because substance Y, the boiling point that we have is higher than the melting point of our naphthalene. You got it, right? You must make sure the boiling point that you have must be higher than melting point of naphthalene because you don't want the substance to boil before the naphthalene is melted. That's it. So how to put it in the proper words? That is how it looks alike. This is how it looks alike. Okay. So we choose substance Y to put in a beaker. Why? Boiling point of substance Y is higher than the melting point of naphthalene. Okay, let me know in the chat box, are you okay with how to solve this? Are you okay with this question? Okay, can all right, good. Okay. Okay, so guys, with that being said, we are all done with heating curve. I hope by this moment, you can understand your heating curve a little bit better now. I hope you should understand your heating curve slightly better now. Not very hard one. If you really get the idea, it's quite easy one actually. Yeah, heating curve. So now we will go on and learn cooling curve. So we will go on with cooling curve. All right. So cooling curve. Okay, so this is, okay, guys, this is the thing. If you fully understand heating curve, you should have no big problem when you come to cooling curve. Seriously, yeah? If you understand heating curve, you shouldn't have a big problem when we do cooling curve. Okay, come, let's start. What is cooling curve? So cooling curve is also a staircase, but the staircase is going down. That's it. Okay, cooling curve, the staircase is going down. So same thing, maximum 2 staircases, maximum 2 staircases. So sometimes we have 2 staircases, sometimes we only have 1 staircase, okay? So when you have 2 staircases, you should know the first process is condensation. Because when you cool down a gas, they will condense first. When the gas condenses, it becomes liquid. Then you continue to cool down the liquid, then the liquid will do freezing to become solid. So when you have 2 staircases, the first staircase is condensation, second staircase is freezing. Like when you have heating curve, when you heat a substance, what happened first? Melting. After melting, then only boiling. Is okay? Heating curve, melting, then only boiling. Cooling curve, condensation, then only freezing. But today, if they only give you 1 staircase, then you all have to be very careful. Because if they only give you 1 staircase, maybe it is condensation, maybe it is freezing. So how to know which one is it? How to know which one is it? Okay, you have to read the question carefully. In this case, you have to read the questions very carefully. Okay, so if the question say this is a cooling curve, this is a cooling curve for liquid X, then you should know already. When you have a liquid, you cool down the liquid, then it is freezing, isn't it? When you have a liquid, you cool down the liquid, is freezing. But if the question say this is a cooling curve for gas A, so you have a gas, you do the cooling. When you're cooling down the gas, it's condensation. Okay, so that's why you all have to be very, very careful when you all have to be very careful when you have one staircase. Huh? All right. So now, same thing. When we do the cooling curve, when we do the cooling curve, okay, we always want to ensure that we have uniform cooling as well. Okay, just like heating, you want to have uniform heating. Cooling process, you also want to make sure that you have a uniform cooling process. So this is the experiment setup for the cooling curve. This is how we perform the cooling curve experiment. So initially, this is a liquid. We want to cool down the liquid to make it become solid. We want to cool down the liquid to make it become a solid here. All right. So now, okay. Okay. All right. Okay. So now, how are we going to do this thing? Okay. So you see, first of all, this is the thermometer. Thermometer put in the liquid so that we can measure the temperature, because cooling curve is temperature versus time. So we need to measure the temperature using the thermometer. Okay. So when you want to do the cooling process, you see here you put a beaker, or you can put a conical flask. You see, now this is super, super tricky. Okay. When you do a cooling curve, okay, this tube you must put inside a beaker. You must put this thing inside an empty beaker, okay? Or you can put it inside an empty conical flask. Okay, this is a conical flask, and this is a beaker. And nothing inside, there's no liquid inside one. It's totally empty one. I'll tell you why later, yeah? You must put the thing inside a beaker, or you must put the thing inside a conical flask. Okay, why? Why we need to do that thing? Why we need to do that thing? Because, all right, by right, your cooling curve should look like this, okay? Which is okay. All right. But when you do a cooling like this, if you don't put in a beaker, if you don't put in a conical flask, what happens? During the cooling process, maybe sometimes you have some wind, okay? Maybe sometimes you have some wind that is blowing. So when the wind is blowing, what happens? Wind will speed up the cooling process, or in the other word, wind will make the cooling process very, very fast. Do you ever have this experience? For example, let's say when you go to swimming pool, let's say when you first got up from swimming pool, your body is wet. Your body is wet. You feel cool, but still okay. Then all in sudden, there is a wind blowing at you. So then what happened? You feel freezing cold. You feel, oh my God, very, very cold. Okay, why? Wind will always speed up the cooling process. The wind will always speed up the whole cooling process. So when the wind is blowing to the liquid, the cooling process happen too fast. Then your cooling curve will become a bit problem. Your cooling curve will become like, you see, your cooling curve by right should be like this. Cool down slowly, 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 like this. Then this turn out slowly. Now, when the cooling process too fast, it might like roller coaster, roller coaster, go all the way down. Okay, roller coaster, all the way down. All right. So cooling happen too fast, then only cover back a bit, then become this. So can you see your cooling curve now like a bit chat already? Why? Your cooling curve now got a hole. Am I right? True not? Initially should be like this, staircase, but now your staircase got one lubang, got one hole already. So this lubang or this process, we have a words for it. We call it super cooling. The cooling process happen too fast. Why cooling process happen too fast? Because there is wind. There is a wind. So how to solve the problem? When we put this thing in a beaker, okay? When the wind is blowing, the wind is blocking by the beaker, just like you are hiding in a house. You're hiding in a house. So when you're hiding in a house, Let's say outside got rain. You scared or not? No scared lah, or not. Outside got wind. No, nothing lah. You hide in the house ma. The house act as a shield to protect you. They block away the wind from you. Same thing, if you don't want to hide in a beaker, you also can hide in a conical flask. Same thing, when you hide in a conical flask, the wind come over, it won't kacau you. Okay? So guys, so why we need to put a beaker or conical flask? We want to ensure that we have a uniform cooling process and we want to avoid super cooling. Okay? So let me know in the chat box, are you okay with why we need to use beaker and or conical flask? Are you okay, guys? So guys, can you see common sense, right? When you do heating, you want a uniform heating. How to do uniform heating? Water bath. When you want to do cooling, you want a uniform cooling. How to do uniform cooling? Empty beaker or empty conical flask. Hey guys, don't put anything. Don't go to put liquid inside the beaker. We are not doing a heating curve now. This is not a water bath. The beaker and the conical flask is empty. There's nothing inside there. There's nothing inside there. Yeah? All right. Okay, one more thing. Okay, normally when after we put this a beaker or conical flask, we do one more thing. Thermometer, we kacau also. Why thermometer we need to kacau the liquid? Because when thermometer kacau the liquid, you can ensure the whole liquid cooling down or cooling process is uniform. So not just like, let's say today I go to drink Milo ice. Okay? So now, if you didn't go to stir, if you didn't go to kacau, what happened? Your Milo ice, maybe your Milo ice, here got many ice batu, here got many ice. Here is your Milo. So maybe this part is very cold, this part not so cold. Am I right? So if you go to take a spoon or a straw to kacau a bit, then the whole Milo ice, the temperature is the same. So the cooling process will be more uniform. Okay? So how to ensure we have a uniform cooling? We do two things. Number one, we put the boiling tube into a beaker or conical flask. Number two, we stir the liquid. We do these two. Okay? But watch out, in SPM, sometimes they force you to choose a poison. Okay, guys, what do I mean they force you to choose a poison? This question really came out this year, SPM 2023, which happened a few weeks back. Just happened a few weeks back. This question asked, which of the following is the most suitable method or most suitable procedure to ensure to avoid super cooling? Okay, this question really being asked this year, all right? So super cooling, to avoid super cooling. Okay, answer A. All right, use water bath. Answer B, put in a conical flask. Answer C, stir the liquid using thermometer. Stir the liquid using thermometer. Answer D. Okay. Go to use Bunsen burner. Okay. So first of all, among the four answers here, which one is the most impossible answer? A and donkey. Because water bath and Bunsen burner is used for heating, heat something, not cooling. So A and donkey is the worst answer you can choose lah. So answer B and C, if you notice, the conical flask and stir the liquid both can help us, isn't it, to ensure we have a uniform cooling and avoid super cooling process. But in this case, they ask you to choose the best answer. So if you want to choose the best answer, guys, which one is more important, everyone? This one, stir. Okay. guys, you see, even today, you don't have the beaker, but you go to stir the liquid, it will still help you to avoid super cooling one, no problem. So actually, stir the liquid is more important than the beaker or conical flask. So the best answer is D. So this is what I call choose the poison. Okay, like answer B and answer C both are correct, but which answer is the best? Answer C is the best. Let me know in the chat box, are you okay with this? Okay, all right. So in this case, you are no longer choosing the right answer. In this question, we are choosing the best answer because there are two correct answers in this case. So when you have more than one correct answers, then you should choose the best one. You should choose the best answers. Yeah. All right. Finish. Okay. So that's it. Okay. So now we already have this thing. Okay. So now cooling curve, you see, okay, this is the normal cooling curve. This is the cooling curve with super cooling process. This is the cooling curve which have super cooling process. Yeah. Okay, now let's see what is happening now. Let's see what is happening. All right, here. Okay. So same thing. Let's say today I want to do a simple freezing process. Okay, let's say I want to do freezing process. So you should know freezing process at here, freezing not started yet. Okay. Let's see. Okay, I get a question in the chat box. Uh, Teacher, is B wrong because they didn't say empty beaker? No, nothing to do with empty. Even just now the question, the beaker is empty. You also cannot choose it because among beaker and also stir the liquid can help us more to prevent the super cooling. So nothing to do with whether the beaker is empty or the beaker got liquid. That is not the main concern. That is not the main concern. Yeah. All right. So now let's come back to here. Yeah. So in this question, okay. So this is freezing. So over here, the freezing not started yet lah. When you not yet freeze, not yet freezing, when freezing not started yet, everything is liquid lah, true not? So we know this is the freezing process. Here is the starting of the freezing, and this is where the freezing ended. So during the freezing process, remember we learned when you are on the horizontal line, you always have two states. When you are on the horizontal line, you always have two states. So when the freezing process is ongoing, when the freezing process is happening, is ongoing, you will have liquid and solid. Some liquid already freeze, become solid, but some of the liquid, they not yet freeze. Yeah, so liquid plus solid. So from here, starting at here, the freezing ended. So this whole thing, when freezing ended, all the liquid already become solid. Yeah. So this is not very hard. If you understand heating curve, this one shouldn't be too hard for you. If you really understand heating curve, this one really shouldn't be too hard for you lah. Okay. So as simple as that. As simple as that. Okay. So now let us try to okay, let me show you another one more last thing. Okay, here. All right. So now we need to explain what is happening. But before that, guys, are you guys okay with this concept? Are you okay with which region and you get what state you have? Are you okay with this? So this is not very hard, right? So not guys, I told you if your heating curve is okay, this part is okay also because you will see a lot of things in common one. There are so many things which is repeating and there are something in common one. Yeah. All right. Okay, now let's go for the last thing. Let's go for the last thing for cooling curve. You see cooling curve very fast, right? Not cooling curve, like we finish the whole thing like in about 30 minutes. So guys, please give me about 5 minutes, about 5 to 10 minutes to finish off with the last part of the cooling curve. Okay, now so we need to know how to explain what happened at here and what happened at here. Okay, what happened at here and what happened at here. Okay, so first of all, over here, so the freezing process not started yet. So imagine you have a liquid. So you first started with a liquid. Now you want to cool down the liquid. Okay, you are doing a cooling process. You're doing a cooling process. So when you're cooling down the liquid, what happened? Cooling process, the heat will come out one. So remember, when heat go in, it's a heating process. When the heat go out, it is a cooling process. Okay, so cooling means we throw away heat from the substance. We throw away the heat. This is a cooling process. So imagine this, everyone. So liquid, how the liquid looks alike. The liquid looks like this, or not? Let's say lah. So all the liquid got energy lah. Again, this energy called kinetic energy. So this liquid, we call it as kinetic energy. Okay, so let's say this is the energy for liquid. So now when we do the cooling process, what happened? The liquid need to throw away the heat, right? So not the liquid need to throw the heat away, because remember, cooling process need to throw away heat. Heating process need to absorb the heat. So you throw the heat, okay, to the surrounding. The heat that you throw, okay. So now you see what happened. You throw the heat, you throw the heat, you throw the heat. Okay. So this is called heat loss. Okay. You throw the heat to where? You throw the heat to surrounding. You throw the heat to the surrounding. So when you throw the heat to surrounding, what happened, guys? Imagine, initially you have 11 ringgit in your pocket. You throw some money to the surrounding. Let's say you throw 2 ringgit to surrounding. You left 9 ringgit. This fellow got 10 ringgit. Let's say you throw 2 ringgit to surrounding. You left 8. Okay, you see that? So when they throw away the energy to the surrounding, they will have lesser and lesser energy. Am I right? So what is their energy? Kinetic energy. So when you throw away the energy to surrounding, the kinetic energy is lesser. When kinetic energy lesser, what happened? Kinetic energy got one sibling. Guys, tell me in the chat box, who is the sibling of kinetic energy? Who is the sibling of kinetic energy? Who is it? Temperature, isn't it? Temperature. Okay, temperature. So when kinetic energy decreases, temperature also decreases. That's it, no? That's what you see. At here, the temperature is actually decreasing. So how to explain? If they ask you what is happening here, why the temperature decreasing? So this is your answer. Okay, the liquid particle, the liquid just now, lose the heat energy. True or not? They throw away the heat. They throw away the heat. When they throw away heat, so their kinetic energy decreases. Am I right? They have lesser and lesser energy. Why the energy lesser? They throw away, ma? They throw away the energy. That's why the energy is lesser. When the energy is lesser, what happened to temperature? Temperature also decreases, because temperature always follow kinetic energy, isn't it? So let me know in the chat box, are you okay with this thing, everyone? Are you okay with this part? Are you okay with how to explain it? So quite easy, During the cooling process, the liquid throw away heat energy. When you throw away heat energy from your body got less and less kinetic energy. When the kinetic energy is lesser, the temperature eventually also becomes lesser. That's it. Okay? So as simple as that. So I don't want you to memorize this long, nonsense, boring sentence. I want you all to know the picture. Understand? Use the picture that I show you just now. Okay? When you have this picture in your mind, everything is easy. Okay? So give me some time. Let me finish this one. Then we are all done with today's lesson. Is okay? This will be the last part. This will be the last part. Okay. So now, what is happening here? All right. So this is important. This is freezing process. So we know during freezing, during boiling, during melting, during condensation, when we change from one state to the other, solid to liquid, liquid to solid, liquid to gas, gas to liquid, something like that. When we change the state, the temperature always constant. So why the temperature is constant? you cannot use the answer you learned just now. Because the answer we learned just now, all the heat absorbed is used to cut. That one cannot. That one is only for heating curve. Understand? The answer that we learned just now is for heating curve, but this is cooling curve. So you cannot use the answer just now. So this is another story. This is totally different from what happened just now. So let me try my level best to explain to you. Hopefully you all can imagine what is going on. So everyone look at here. Freezing. So why during the freezing process the temperature didn't change? Okay, freezing, what happened, guys? Freezing convert the liquid to solid, isn't it? Freezing convert the liquid to solid. Okay, so when liquid convert to solid, the picture will look at this. This is some liquid, so they will become solid like this. So to convert liquid to solid, what we want to do, we want the liquid to stick together. Understand? We want the liquid to stick together. Then only they can become the solid. So just like this. You are a liquid. I am a liquid. So if you want the liquid to become solid, the liquid need to stick together. They need to hold their hand together. Yeah. So this is what we wanted to do. Okay. They need to stick together. Okay. So now I want you to see why during the freezing process, the temperature didn't change at all. Why? Okay. So first of all, let's look at the liquid. All the liquid got energy one. So remember, all the liquid here got energy. This energy called kinetic energy. Okay, let's say now imagine this guys. I want you to imagine okay, when we do cooling curve, when we are doing cooling curve, we cool down the substance. When you cool down the substance, what happened? They throw heat to the surrounding, isn't it? When you cool down the substance, they throw away the heat to the surrounding. So what is the name here? The name is called heat loss to the surrounding. They throw away some heat to surrounding. Now you see, guys, by right, when you throw away energy to surrounding, you should have lesser energy. Am I right? You should have lesser energy. So when the energy is lesser, the temperature should be lesser. But why the temperature didn't change? Why if you look at the graph, the temperature actually didn't change at all. Why? Because of this. You see, everyone, when you do the freezing, the liquid need to join together to form solid. Open your eyes, big, everyone. Open your eyes, big. How to join together? Imagine this, This is liquid and liquid. They want to join together. So I am a liquid. You are a liquid. So we want to hold our hand, join together. Yeah. So I want you to look at the blue color thing. Okay. I give you my hand. You give me a hand. Join together. I give you my hand. You give me my hand. Give hand. Join together. So why they want to join together? They join together because they want to become solid. Because liquid need to stick together. Liquid need to join together. Then only they form solid. And I want you to know this. When something join together, they will give energy. When something join together, we will get extra energy from them. Okay, just like this, guys. Okay, just like this. Okay. Let me talk about something not related to chemistry. Let me talk about something not related to chemistry. Do you ever have this experience? Let's say you are very scared. You feel very scared now. You are so fear. You are in fear. Then all in sudden, somebody that you trusted come and hold your hand tightly. It can be your parent, your father, your mother. It can be your sibling or anyone who you trusted. So now you're very scared. You are so scared. When someone holding your hand, somehow you feel more relaxed or you feel more calm. Why? There is a saying in English, okay? I will give you the strength. I give you the strength. So the strength here is energy. The strength here is energy. So I want you all to imagine when I hold your hand, you hold my hand. Both of us, we get energy from there. Okay? I hold your hand, you hold my hand, you got energy, I got energy. I want you to understand this story first. So now let's look at here. This is me. This is you. I hold your hand. You hold my hand. When we holding hand, I got energy. So holding hand, I have extra energy. So the energy given to me. When you hold my hand, I got extra energy given to me. So I want you to imagine this. So come back to here. When they holding hand, give energy, give energy, give energy, give energy, give energy, give energy. So what happened is this, okay? Although here I throw away the heat to surrounding, let's say I got 10 ringgit, I throw 2 ringgit to surrounding. But when I holding hand with other people, we get extra energy, we get extra strength. I hold your hand, you hold my hand, we get extra energy. So this extra energy also 2 ringgit. So 2 ringgit come in again. So 10 ringgit, throw 2 ringgit away, 2 ringgit come in. So how much energy you have? Still 10 ringgit, right or not? Your energy didn't change. Why? The energy you throw away just now, exactly same as the energy you got back when you're holding hand with other people. Why you want to hold the hand with other people? I want to form solid. Liquid need to hold the hand together to form solid. So how to put this in words, everyone? Look at here. When freezing is taking place, when freezing is happening, heat loss to the surrounding. Okay, you can write LOST, LOSS. Doesn't matter what. Doesn't matter. Okay? Heat loss to the surrounding is exactly balanced by heat release during formation of attractive force. Okay, what do we mean by formation of attractive force? Holding hand. Okay? When we holding our hand, the blue color is called formation of attractive force. Okay? We want to form the force, we want to stick together. Formation of the attractive force. When you form the force, when you form the extra forces, they will release energy. Okay, I hold your hand, you hold my hand, we get extra energy. That extra energy called heat release. So can you see that? The heat loss to surrounding, okay? I throw energy to surrounding, never mind. I got back extra energy when I'm holding other people's hand. So that's why my energy is still the same. So kinetic energy no change, temperature no change. Guys, let me know in the chat box, can you imagine this? Can you imagine what is going on here? Can you imagine what is going on here? Kimberly asked, can we write formation of bond? Cannot, Kimberly. I told you just now, right? Cannot use the word bond. Cannot use the word breaking bond. Cannot use the word forming bond. Don't use the word bond. Use force of attraction, please. Use force of attraction, or you write attraction force. Don't write the word bond. Yeah, don't write the word bond because they don't accept it. So I hope you guys can imagine now what is going on here. You got it? So why the temperature didn't change? Because when you do freezing, the heat you throw away is exactly same as the heat that you got back when you're holding other people's hand. Why you want to hold other people's hand? Liquid and liquid need to join together. They need to hold their hand together in order to form solid. And the process of holding hand will give extra energy, which we call heat release during formations of attraction force. Yeah, we will do more and more questions on this by next week. So hopefully, and then those questions will definitely give you a much better idea on what is happening. Yeah, but I hope as per now, as per now at this moment, you understand the concept of cooling curve and you understand why during the freezing process why the temperature didn't change at all. That's why you all can see, they always love to ask this one. Why temperature didn't change in the heating curve? Why temperature didn't change in the cooling curve? They always love to ask this part. Okay? I really hope you all can see that. We will do a lot of questions on cooling curve next week so that you know how to apply whatever thing that we learn. Okay? So I think that's all for today. Yeah. I hope you learned something. All right. And I'll see you guys again by next lesson then.